In the last lesson, we talked about identifying the oxidation number of all the elements in a chemical formula. In this lesson, we are going to look at the changes from reactant to the product side. That is to say, if the reactant is either being reduced or oxidized. So how does that work? First of all, from reactant to the product side, if an atom oxidation number decreases, and the only way that's possible because it is gaining the negative electron to cancel out that positive, that atom or coming from the reactant is considered reduced through the reduction process. Vice versa, if an atom going from reactant to the product side and that particular atom oxidation number increases, that's it. The only way that's possible is because it is losing the negative electron to become more positive. Okay, so therefore that particular reactant or atom is considered as oxidized through the oxidation process. If you have a hard time, always think about Leo. The line says Ger, Leo lose electron oxidation, Ger gain electron reduction. So let's go back and look at our reaction and identify which of the reactant, not the product, is being reduced or oxidized. First of all, we have to identify the oxidation number of each of the atoms in the reaction. In this case, we look at copper, and copper is starting from +2 to 0. And how is that possible? We know that the oxidation number decreases. But to think about it in terms of electron, the only way that's from positive to become less positive, that is gaining the negative electron. So we can say, hey, it is gaining negative electron, and that is the reduction process. So what does that mean about this substance? This substance is actually being reduced. Then for oxygen is -2 and -2 on both sides, and therefore, so is neither being reduced or oxidized. For zinc, Zn is starting from 0 all the way to 2+, and the only way that's possible because it's losing the negative electron, so we have lose negative electron, and that is oxidation. Therefore, zinc is being oxidized. Notice how I use the term reduced and oxidized to describe the reactant, not the product. And sometimes they use a common term called species. But that's just saying what is the substance in the reaction, or species in the reaction, that is being reduced, oxidized. Now let's try another problem. In this case, we have hydrogen starting from +1 and end up with +1, so there are no changes. For sulfur, we have 2 sulfur in 2 different places on the reactant. But again, they all belong to specific reactant. In this case, this sulfur belongs to this reactant, and we have, hey, -2 going all the way to 0. What does that mean? It is becoming more positive, and the only way that's possible is lose electron. So when it loses electron, it undergoes the oxidation process, and therefore we have this is being oxidized. Where if we look at this sulfur, it has a +4 and it's going from +4 to 0. And the only way it becomes less positive because it is gain electron, and that is the reduction process. Therefore, this sulfur in this reactant is being reduced. In this case, we have 2 sulfur in 2 different reactants. In this sulfur, it is being oxidized because it loses electron, and in this sulfur is being reduced because it gains electron. Let's try another problem. Here we have manganese in this case, starting from +4 all the way to +2. In this case, the oxidation is less, so therefore the only way that's possible is gaining electrons, so we have gain electrons, and that is reduction. So therefore this substance here is being reduced. And if we look at oxygen, -2 and -2 in the product as well, so no change. For hydrogen is +1 and +1, no change. For chlorine we have -1, then we have -1 here, then we have 0. So therefore there is a change. Even though there are no changes between this 2 chlorine, but it is a changes between that chlorine and this chlorine because its oxidation numbers increase. So it loses electron, and that is going through the oxidation process, that tell you this chlorine or that reactant right there is being oxidized. Lastly, we have this complicated reaction. Here we have potassium plus 1, but potassium stay plus 1 on the product side as well. Then we have manganese again, plus 7 going to plus 2, and the only way that's become less positive because it is gain electron, the negative electron. So it's undergo reduction process. That tell you this right here is being reduced, specifically the Mn in that reactant. For oxygen, it's -2 and it stays -2 on this side as well. And for hydrogen, +1 and +1. For chlorine, -1, it has -1 on the product for this part. And that's -1 again. But once you get over here, it has a 0. So we can see there is a change in electron there. So in this case, -1 to 0, that tell you that it is losing electron. That lose a negative, that's why it become more positive. So lose electron, that is oxidation. So therefore, this is being oxidized.